This is John Black, Super Chemist. I'm here to talk about amphetamines and amphetamine derivatives. I'm trying to bring in some subscribers. There's a picture of it. Basically, all amphetamine is a benzene ring, propane with an amine. All right. Well, what's the difference between amphetamine and methamphetamine? Only difference is up here. One of the H's, right? There used to be two, now there's one, is replaced by a methyl group. That's why you call it methylamine, because it's an amine with a methyl group on it. Now, I'm not going to get into isomers, optical isomers, but just to let you know, when you see like a small d or a small l, and that corresponds to a positive or a negative, they're talking about optical rotation, okay? When they use a big D and a big L, they're talking about chirality, okay? Same with a meso product if you have more than one chiral center. But I'm not going to go into these that much, you know what I mean? This is getting too complicated for most people, and I'm not really getting into the chemistry of it, just the analogs or derivatives of it. But to let you know, these all have, this has a chiral center, this has a chiral center, so therefore, there's an L and a D, or an R and an S. See, these D and Ls, they're used in biology. They're kind of stupid. They're nonsensical for a chemist because you could have 10 chiral centers and they're still giving you a D or an L. This basically corresponds to a specific chiral center if there's more than one, and it's the one that helps the molecule react with your biochemistry. You know what I mean? The other chiral centers probably don't have anything to do with it. Only one chiral center does, and that's the one they pick. You know what I mean? Like sugars are always D, because the L doesn't, it doesn't link up with our biochemistry. The D does. Same with amino acids. They always use L. They never use D, because D, that isomer does not correspond to our chemistry, our biochemistry. You know what I mean? It's the same here. A lot of people think a racemic mixture is the best. That's where you have 50% L, 50% D. Now, if you're in chemistry, they use R and S, and they distinguish each chiral center. But I'm not gonna get into that. That's irrelevant. Like I said, here's amphetamine. Here's methamphetamine. And this would be what I'm talking about, like a chiral center, D or an L. See how this is the same exact molecule, but see the benzene ring and the propane, they're in the plane of this board, right? The NH2, this one is coming out of the board, and this one is going into the board. So it's the same exact molecule, but one is left and one is right. You know what I mean? One is Devo, one is Levo. One is D, one is L. One is R, one is S. You know what I mean? But I'm not going to get into that because it's really irrelevant. Now, what is Sudafed? Back in the day, you can't do it now. They might sell Sudafed, but you got to have a prescription. You can only buy so many. You got to give them an ID. And they're keeping track of every box. You cannot just go in and buy. They used to limit it to 3 boxes per customer. Then they started putting it behind the counter where you needed ID. Now it's like, unless you're going to break into a store and steal their crap, and they ain't going to have no big volume there for you to steal. This is a useless experiment, but just to bring it up because it was so prevalent, this is ephedrine. You can see the only difference between it and methylamine is there's a hydroxy group right here. Now this is pseudoephedrine. It's the same exact thing as this. The only difference is the chiral centers. There's 2 chiral centers now because you got the OH. These are opposites, see, RS, SR, whereas these are the same to get the pseudo. You got an S and an S. Now, if you wanted to know what, the corresponding Sudafed product that would go to because they have a methyl group, so they go to the methylamine, right? And you just take off the OH, and you have methylamine. What if you wanted to do amine? You would get phenylpropanolamine, which is another Sudafed type product, active ingredient. And you can see there's no methyl group. So when you take off the OH, you'll have amphetamine instead of methamphetamine. And the reason why this is possible is because this is at the benzyl position. A hydroxy group at the benzyl position can easily be taken off with either hydrochloric acid and phosphorus or iodine and phosphorus, and you make the HI, the hydrochloric acid, in situ, and everything would be recycled. Like, it's a circular reaction. Whereas you use up your stuff, you make more of it. So it's a continuation. Now, what is MDA and MDMA, which is ecstasy, most people call it? What's the difference between that and amphetamine? Here's a picture of MDA. Here's a picture of MDMA, okay? And if you take off this part over here with the oxygen, and a methylene group, you'll be left with methamphetamines here. And if you take off the methylene dioxy group over here, right, you'll be left with amphetamine. That's the difference between amphetamine and MDA, is it has this methylene dioxy group attached to the ring. What's the difference between methamphetamine and MDMA? Again, you have a methylene dioxide group on the benzene ring. That's what this stands for, methylene dioxy methamphetamines. Methylene dioxy amphetamines, MDA. They're both ecstasy. Now, these aren't the only forms of ecstasy. There are other forms of ecstasy, okay? And I'm just going to give you one example, okay? Now, I want you to look at these two molecules here, all right? That's another form of ecstasy called V instead of X, okay? What's the difference? Remember, we had an oxygen, and then a methylene group here, right? The only difference is this methylene dioxy group got broken in half, okay? Just think of it. If you took this H off, right, and you put a bond down to the C, you would have MDMA, right? Over here, same thing. If you took the H off and you drew a line to the carbon, you'd have MDA, right? This is actually called an active metabolite of MDA and MDMA. And what that means is, when you take MDA, your body metabolizes at least some of it into this. Okay, well, not all of it, some of it into this. It breaks the bond here and makes the hydroxy group. Same over here. It breaks the methylene dioxy and makes a hydroxy group. So when you take MDA or MDMA, you're actually taking this also, because some of it, a fraction of it, will be broken down into this. Now, these are actually a stronger form of MDA and MDMA. I don't know why people would make MDA or MDMA when they can make this. It doesn't really make sense, but whatever. I want you to see something, okay, on how these products are made. And I'm not going into really how to make it. More about the similarities in making it. Now, I want you to look at this top reaction. You got benzaldehyde, nitroethane, primary amine as your catalyst, and you will make this nitropropene. You can reduce it. I can name 100 ways to reduce it. You can use a hydrogen bomb. You can use DC lab source. There's 100 million ways. But anyways, when you do reduce it, you change the double bond into a single bond, and you change the O's into H's. And what do you end up with? You end up with amphetamines. Well, what would happen if you started out, instead of benzaldehyde, you start out with this product, right? What are you going to make? You're going to make V. See, because it's the same exact thing. The only difference is you already attached the stuff onto the ring, right? What is this? This is basically vanillin. Okay, the flavoring in vanilla. And you'd make V. Now, what if you wanted to make X, ecstasy, MDA? Well, instead of starting with benzaldehyde or benzaldehyde with that on it, you start with benzaldehyde with the methylene dioxy group. Do the same thing, nitroethane, primary amine, You get your nitropropene, but you'd have your methylene dioxide connected on there. Then you reduce it, and you end up with MDA. Now here's a couple places to get a benzene ring with a methylene dioxide at the 3,4 position compared to something else. Just like up here. See, I got the methylene dioxide group. One is safrole, and that's sassafras. I know I'm spelling this wrong, but sassafras oil is 90% safrole, or somewhere around there. It's a lot, maybe even more than that. Although it's impossible to get anymore. But you can see you can use this as a starting material for MDA or MDMA, and also pepperin, which is from black peppers. You can see it has the methylene dioxide group on the benzene ring, and if this was considered 0.1, it'd be 2, 3, 4. See, the methylene dioxide is at 3 and 4 on both of these. So you could use this as a starting material. You know, and it all depends. You know what I mean? Like benzaldehyde, you get out of bitter almond oil, right? But there's other derivatives, like you can get nutmeg. Nutmeg has, I think, mysterion in it or something, and I think it also has a methylene dioxide group, but it has something else attached here. But there are hundreds. Well, I don't know about hundreds, but there are a lot of different things. Maybe dill oil, like I said, vanillin. You know, there's just a lot of different derivatives, and the starting materials come from different oils. Anyways, that's basically the differences. I mean, there's a lot of analogs. It depends on what is on your ring that you start with. You know, depends on what you end up with. And different things on the ring do different things. You know what I mean? This methylene dioxide ring makes it more of an LSD type drug than amphetamines. You know what I mean? Putting taking a hydrogen off of the amine part and putting a methyl on there, that makes it more LSD too. You know what I mean? Some parts you take off or put on, they make it more a jittery or up high. Some make it a more hallucinogenic type high, even though you don't hallucinate. But you know what I mean? That body heat that you get, or that I forget what they call that. But that's what determines what the drug does, is these constituents on it. You know what I mean? Amphetamine will keep you up a lot longer. Methamphetamine, because you put a methyl group on there, it doesn't keep you up as much, but it gets you high in a different way. You know what I mean? Each one of these do a different job. But anyways, just trying to pull in some subscribers. Talk about something I know people want to hear about. So you can see that amphetamines, methamphetamine, MDA, MDMA, ecstasy, V, and the hundreds of other amphetamine derivatives are all made basically the same way. Okay. Only difference is when you do your reaction, whatever extra groups you have on there, you start with, you know what I mean, when you do your reaction. You know, if you want V, you make sure you have these constituents on your ring. You want MDA, you make sure these constituents, you know, you got a methylene dioxide group on your ring. It's that simple. Amphetamine and amphetamine derivatives are actually an easy drug to make. I mean, God, there's only 3 parts to it. You got your benzene ring, you got your propane, and you got your amine. There's only 3 parts to it. It's not like it's a big giant molecule. Anyways, I've at least found it interesting. Everybody have a great day, and always remember, science is great.